Hey guys, welcome to the last section in BC, section 9.6, polar area, the area between two curves in polar form. So if f is continuous and non-negative, then the area is given by these formulas. Here's the big idea. This is the one that you need to remember. The area, 1/2 between the two angles, r squared d theta. So it's 1/2 r squared integral r squared d theta. How do I find those two angles, alpha and beta? Suppose they ask us to find the area of a given shape. We need to figure out where the shape starts, it's usually 0, and where the shape ends. It doesn't always go to 2 pi before it repeats. So how do we know when this happens? That's when a graphing calculator comes in handy. The calculator sketches the 2 pi, so we can see how many times the shape is sketched in that interval. So I'm going to need my calculator. And I'm going to need to switch it around a little bit. I'm going to switch the mode to polar. Now when I go to y equals, and I want to change this to that, so I can see the little circle as it goes around. Find the area enclosed by that function. Well, that's pretty easy. 1/2 the integral of r squared d theta. I'm only missing one thing, and that's my bounds. So I'm going to graph this, and I want to see if it just goes around once or if it repeats itself. So there it's going. And here it comes back. It doesn't repeat itself. It goes around a circle and stops. So my interval is from 0 to 2 pi. Now I'm going to turn my calculator back from polar mode into rectangular mode so that I can do this integral. So I want to integrate. I'm going to go ahead and put the 1/2 in there. Parentheses 2, parentheses 1 plus cosine of x squared. Second trace 7. From 0 to 2 pi. And I get about 18.850. So the hard part for polar area is figuring out where that thing repeats. And I'll give you a sheet that shows you a little shortcut to help you remember this. But for now, just be able to use your calculator. The area of one petal of a rose curve given by r equals 3 cosine 3 theta. So let's go back to polar mode. Y equals 3 cosine 3 theta. Now let's watch how many times this thing goes around. Oops, what did I do wrong? Oh, too many parentheses. And I forgot to do, let's do this again. You have to make sure that you have the little circle donut thing, or else you can't see how many times it goes around. 3 cosine 3 theta. So there's it going around to make a rose. So there's 1, 2. So this thing travels twice. So this draws the rose, draws a 3-flower rose twice in the interval 0 to 2 pi. So it draws a 3-flower rose twice in the interval. So how would I find the area of the rose? The area of the rose is going to be 1/2 r theta squared. But from where to where? Well, if it goes all the way around twice in 2 pi, how long does it take to go around once? 1 pi. So this will give me the area of the entire rose. But I don't want the area of the entire rose. I want the area of 1 petal of the rose. If it's 3 petals and I want the area of 1 petal, I'll be 1/3. So let's grab my calculator. Let's go to y equal, oh, I need to turn it back to regular mode, to my function rectangular mode. So I'm going to cheat and put 1/6 in here so I don't have 1/3 and 1/2. 3 cosine 3x squared. Second trace 7. From 0 to pi. And I get about 2.356. As always, guys, we're going to practice this a lot more in class, so if you have any questions, you can ask then, or come see me before school, after school, or during study hall. Thanks.